Section 1. What is machine learning? Learning objectives. By the end of this section, learners will be able to 1. Define machine learning (ML) in simple, practical terms. 2. Understand the difference between traditional programming and machine learning. 3. Explain the roles of training and inference and how ML works. 4. Recognize everyday examples of ML without requiring technical detail. Let's start with the big question. What is machine learning? Machine learning, often called ML, is a way of teaching computers to learn from data and experience, rather than just following rigid rules. Traditional programming versus machine learning. Imagine we want to create a computer system that can tell if an email is spam. Traditional programming approach. A programmer writes a long list of rules. If the subject line contains "win money fast," mark as spam. If the email has too many exclamation marks, mark as spam. If it comes from an unknown sender, mark as spam. The problem? This rulebook grows too long and misses patterns humans might not think of. Machine learning approach. Instead of coding every rule, we give the computer thousands of emails. Some labeled spam, some not spam. The computer learns patterns on its own. Certain words, formatting, sender behaviors. Then when a new email arrives, it can decide whether it's spam or not without us hard-coding the rules. That's the key difference. Traditional programming equals rules tell the computer what to do. Machine learning equals data teaches the computer what to do. Training versus inference. Study versus exam. Machine learning works in two main stages. Training. This is like a study session. The algorithm looks at many examples with answers provided. It learns the patterns. Inference. This is the exam. The algorithm is shown new, unseen examples, and it has to give the answer using what it learned. Simple analogy. Think of ML as a student. It studies during training and then takes the test during inference. Everyday examples around the world. Machine learning is already part of daily life, wherever you are. A phone camera recognizing faces when you take photos. Predictive text suggesting the next word as you type messages. Online shops recommending items based on what others like you have purchased. Weather apps predicting rain using past patterns of atmospheric data. The amazing part? Machines do this fast, at scale, and consistently. Why machine learning matters. Machine learning enables adaptability. Systems improve as they see more data. Personalization. Each person's experience can be unique, such as playlists, recommendations. Scalability. Tasks too large for humans, like analyzing millions of X-rays, become possible. But remember, ML isn't about thinking like humans. It's about spotting patterns in data. Reflection. Think of an everyday digital service you use. Maybe Google Maps, Netflix, Duolingo, or a photo gallery on your phone. Do you think it's using traditional rules, machine learning, or a mix of both? How would it work differently if it relied only on fixed if-then rules? Key takeaways. 1. Machine learning equals teaching computers to learn from data and experience, not just rules. 2. Traditional programming equal hand-coded instructions. ML equals data-driven learning. 3. ML works in 2 steps. Training, study from examples, and inference, apply to new cases. 4. Everyday examples include spam filters, face recognition, predictive text, online recommendations. 5. ML matters because it allows adaptability, personalization, and efficiency in ways humans alone cannot scale.